Hi, it's Mrs. Smith, and I'm just going to do a quick little overview on understanding atomic structure. This worksheet that you see in front of me that some of you might have had a little bit of difficulty with. So what I'm actually going to do is I'm going to skip down to part B. And so this part here that you're looking at the box, this is from the periodic table. And so the number at the top, this is going to be your atomic number. This is actually the identity of the element itself. So for 8, it's always going to be oxygen. And so the same atomic number is always going to be associated with the same element. The letter down below, it can be one letter or it can be two letters. If it's two letters, the second letter is always going to be lowercase. This is the element symbol. The next one is the element name. And then finally, you have the mass number or the atomic mass. With all of this information, you can easily find out a lot about an element. You just need to know a couple simple rules to kind of help you. And so I'm going to write these rules up at the top, and then I'll refer to these a couple of times. So the first rule is that the atomic number equals the number of protons. The second rule is the number of protons equals the number of electrons, because the atom wants to be neutral. And then the third rule is that the mass number minus the number of protons is going to give you the number of neutrons. We can also say that the number of neutrons plus the number of protons equals the mass number. And that's just a rearranging kind of algebraic look at the equation above. And so if we think about those three rules, and then we go down to number 7, 8, 9, and 10, it's basically thinking about those rules and then rewriting them in a different way. So what does the atomic number represent? Well, if you go back to the rules, the atomic number equals the number of protons. So that's easy, but there's two blanks. And so then you have to think about the second rule. So if the number of protons equals the number of electrons, then think about what the atomic number also equals. Number 8. Okay, you can refer to number 3 in the rules up at the top. Number 9 and number 10, again, just ask you to answer the questions based on those 3 rules. Okay, I'm going to go to the second page for a second, and I'm going to have you look at number 11, because this has been a point of some misunderstanding. All this is looking at those 3 rules. You don't even need to look at a periodic table, because Mr. Suter and I gave you all the information you need. So for the first one, it tells you that lithium, its atomic number is 3. And so if we again remember that first rule, that the atomic number equals the number of protons, then if the atomic number is 3, the number of protons must be 3. If we go to the second rule, the number of protons equals the number of electrons, then if the atomic number is 3, that means the protons is 3. And if the protons is 3, that means the electrons are also 3. The last blank we have to fill in is the neutrons, and that comes from that third rule, that the mass number minus the number of protons equals the number of neutrons. So if the atomic mass is 7 minus 3 for the protons, then we're going to get 4 for our neutrons. And so you're going to be doing that for each one. Now, for some of them, like that, let's look at K, which is potassium. We don't have an atomic number. We don't even have a number of protons, but we do have a number of electrons. And so if you started a different rule, like number 2, you know that the protons equals the number of electrons. So if there's 19 electrons, that means that the protons must also be 19. And if there's 19 protons, then the atomic number is 19. And so then 39 minus 19 would give you the neutrons. What if you don't have the atomic mass? Well, if you have 47 for the atomic number for silver, that means the protons is 47. So instead of the atomic mass minus the number of protons gives you neutrons, if you add neutrons and protons, you'll get the atomic mass. So without giving you all the answers, there's just a quick overview to kind of help you with that information. And then the last part is going to help you both with the first question as well as the last portion. And so with the electrons, we're talking about energy levels when we talk about what each level can hold. In other words, we're looking at the number of rings that are outside of the nucleus. And so the first ring can hold up to 2 electrons. The second ring can hold up to 8 electrons. And then the third ring, this can actually hold more than 8. It can hold 18, but it's really capped at 8. And that's because of this octet rule that we talked about in our notes. The electrons that are in the outermost ring, they're known as valence electrons. And that's really important because that's going to tell an atom whether or not they're going to bond. That goes back to this octet rule. If they are full, so if they have 8 in their second, third, fourth, etc., then they're full and they don't need to bond. The only time they're not looking for 8 is if they're only looking at the first ring because they're looking for 2. So if we look at sulfur, we get the atomic number and the atomic mass in this example. So then using the rules from before, we should be able to get the protons. We should say protons equals electrons. We have that. And then the atomic mass minus the number of protons gives us the neutrons. So for this one, they happen to be all even. For this diagram, you can actually use shorthand for this, at least for my class. So instead of having to draw all the protons and the neutrons for this one, you can actually just write P plus, that's the shorthand for protons because protons are positive, semicolon, and then, colon, and then write 16. And then the neutrons are also in the nucleus, so that's N with what we call N naught or N0 because there's no charge in the neutron, and again, 16. Then what we're going to do is draw in our electrons in each ring. So the first energy level can hold 2. So I'm going to draw 2. Now I have 16. They can't all fit in the first ring. So I've used up 2. So now I have 14 left. The next ring can hold up to 8. Well, 14 is more than 8. So I can fill in this second ring. I like to pair mine in sets of 2 at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock because it keeps 1 nice and even, and 2, it's very easy later for bonding so that I can look at whether or not the electrons are laid out, and it will help with this Lewis structure as well. So then I've used 8 more. So 14 minus 8 means there's 6 left. So there are 6 valence electrons because 6 is less than 8. So I'm not going to fill that outer ring. So I'm going to draw my 6 in. And so you can see here, because I pair mine, that we have this space open. So this is going to want to bond. Because it only needs 2 more, it's likely that sulfur is going to want to gain electrons. If, let's say, we only had 2 in the outermost ring, then I would want to, or this atom would want to get rid of electrons. Because if it got rid of all the electrons in the outermost ring, I'm trying to show them all, I don't have that many fingers, then the inner ring underneath of that, if you look, is full. And so then it would be stable. So depending upon how many electrons it has will be whether or not it gains or loses electrons. And so that kind of goes into that whole bonding. Is it going to share electrons and use covalent bonding? Or is it going to gain or lose electrons through ionic bonding? Remember, ionic bonding is a metal joined to a nonmetal, and covalent is a nonmetal with a nonmetal. And so when we get to Lewis structure, then Lewis structure is basically just the valence electrons. So if I have 6 in the outermost ring, all I have to do is draw the 6. I'm going to draw them a little bit bigger. And again, this will make it really easy when we're bonding later. So on the next page, you're going to do a few more examples of that, where you're going to be drawing each one, both as the Bohr structure, which is the one with all of the protons, neutrons, and electrons drawn, and you're also going to do the Lewis structure. Some people keep forgetting that, as well as filling in the protons, neutrons, and electrons for each one. After you do all of that, there's a couple of questions, and I gave you some hints just a moment ago. If you then go back to the first page, and you go back to that one that's at the top, where it asks you to draw the protons, draw the neutrons, and draw the electrons, it's very similar, except you're actually going to be drawing the circles as the protons and the neutrons and labeling the ones that are positive protons and then labeling the negative electrons as you draw. And so you'll finish that one as well. Remember that the atomic number is the identity of the element. So when you're figuring out number 5, that should help you by looking at the periodic table. Hope this quick overview kind of went over some things to help you complete this diagram, and see Mr. Suter or myself if you have any more questions.